Hi, my name is Graham Smith, and I'm one of the authors that helped develop the learning approach to mathematics that is found in our textbook as well as the video you are about to experience. To learn more about our approach to learning mathematics, visit the web address that accompanies this video. Now, enjoy the video.
Greatest common factor and least common multiple. This video will help you find the greatest common factor by listing factors, find the least common multiple by listing multiples, and also find the greatest common factor and least common multiple by factoring. Greatest common factor. We'll start by taking a look at some definitions. Any number that divides two or more numbers evenly is a common factor of those numbers. The greatest common factor, or GCF, is the largest number that divides two or more numbers evenly. Now let's take a look at some examples that will help us to understand common factors and the greatest common factor. Example 1. Find the common factors of 8 and 12. Well, first thing we're going to do is we're going to list the factors of 8. Well, 1 divides into 8 evenly, so it's a factor. 2 divides into 8 evenly. 4 divides into 8 evenly. And 8 will also divide in there evenly. So those are the factors of 8. With 12, we have 1, 2, 3, 4, 6, and 12. So quite a few factors for 12. Now what we want to do is just find the factors that they have in common. Well, they both have 1 in common, so that is a common factor. They both have 2 in common. That's a common factor. And they both have 4 in common. So those are all the factors they have in common. So those are our common factors. Example 2. Find the greatest common factor of 8 and 12. Well, if we take a look up at example 1, here are our common factors, 1, 2, and 4. From that list of common factors, our greatest common factor is 4. So all we're looking for when we're finding the greatest common factor is the largest factor that both of these numbers have in common.
Least common multiple. Let's start with some definitions. A common multiple of two numbers is a multiple of both numbers. The least common multiple, or LCM, is the smallest multiple that is common to two or more numbers. Now let's take a look at some examples that will help us understand common multiples and the least common multiple. Example 3. Find the first two common multiples of 6 and 9. Well, we're going to start by listing multiples of 6. And remember, to find multiples of 6, we're going to take 6 and multiply it by the numbers 1, 2, 3, 4, 5, etc. So let's start. The first multiple of 6 is going to be 6 times 1, which is just 6. The next one is 6 times 2, or 12. 6 times 3, which is 18. 6 times 4 is 24. 6 times 5 is 30. Let's stop there. We might need some more multiples, but that might be enough to find the first two common. Now let's go to multiples of 9. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. And 9 times 5 is 45. Let's take a look and see if we found any common multiples. Well, in fact, we have. We found the first multiple they have in common, which is 18. It looks like we haven't found any other common multiples, so I'm going to go back up to 6 and list a couple more. So remember, we left off with 6 times 5, which was 30. Now we'll go to 6 times 6, which is 36. And now I can stop because there's the second multiple that 6 and 9 have in common. Example 4. Find the least common multiple, or LCM, of 6 and 9. Well, we found common multiples already. We have both 18 and 36. Of those common multiples, the smallest or least is going to be 18. So the LCM of 6 and 9 is going to be 18.
Now it's time to check your understanding of the greatest common factor and the least common multiple. Hit pause on your video player and answer these guided practice questions. When you're done, hit play to see how you did. Question 1. List all the factors of 12. Well, 1 goes into 12, and 1 times 12 is 12, so 12 also must be a factor. I'm going to kind of work on the outsides here and work towards the middle. 2 goes into 12. Well, 2 times what? 2 times 6. So that's the next largest factor. 3 goes into 12. Well, 3 times what? 3 times 4 goes into 12. And now you can see that 3 and 4 we've kind of met in the middle, so there are all my factors of 12. 1, 2, 3, 4, 6, and 12. Question 2. List the first 3 multiples of 12. Well, multiples of 12 are going to be things that we take and multiply by 12. And we start with 12 times 1, which is 12. That's the first multiple of 12. 12 times 2 is 24. That's the second multiple. And 12 times 3, 36. That's the third multiple of 12. Question 3. Find the greatest common factor of 8 and 16. Well, first we're going to start with factors of 8. So factors of 8. 1, 2, 4, and 8. Factors of 16. There's lots of them. 1, 2, 4, 8, and 16. From this list, we want the greatest factor that they have in common. Well, it looks like they have all of these factors in common, but the one that's the largest is 8. So our greatest common factor is going to be 8. Question 4. Find the least common multiple of 10 and 12. So we want the very smallest multiple that these two numbers have in common. Well, let's look at multiples of 10. 10 times 1 is 10, then 20, 30, 40, 50. Let's see if that's enough. It might not be. We might have to list more, but let's stop right there and see. So multiples of 12. 12 times 2 is 24, then 36, and then 12 times 4 is 48, and 12 times 5 is 60. So it looks like if we go back over to 10 and list one more multiple of 10, which is 60, that is the first multiple that they have in common. So that is going to be the least common multiple of these two numbers. So find the greatest common factor and least common multiple by factoring. When working with large numbers, it is often quicker to use a factoring technique with a Venn diagram to find the greatest common factor and the least common multiple. So you may have noticed we use a new word there, Venn diagram. Let's take a look at the definition. A Venn diagram uses overlapping circles to represent the relationship between two or more things. So now let's take a look at an example that will help us understand what a Venn diagram is. Example 5. Make a Venn diagram that describes the items on each sub-sandwich. So we're going to start here and take a look at some sandwiches just to understand the Venn diagram. So we have two sandwiches. One of these sandwiches is a cold cut sandwich, and it has ham, turkey, and onion on it. The other one is a veggie sub, and that has cucumber, tomato, and onion. So to make a Venn diagram, I'm going to draw two overlapping circles. The circle on the left is going to represent our cold cut. The circle on the right is going to be our veggie. Okay? And what we're going to do is we're going to put these items into the Venn diagram. Well, let's take a look. The center here, we want the items that are common to both of these subs to go in the overlap. That's what that overlap represents. And you can see by our list of items, they both have onion. So that's going to go in there, in the middle, because that's what they have in common. Now, if we take a look at the cold cut sub, that has ham and turkey, but the veggie sub, of course, doesn't have that. So that's going to go over here, outside of the overlap. And that's going to tell us that that ham and that turkey is only on the cold cut sub. And you can see on the veggie sub, we also have cucumber and tomato. And those are not on our cold cut sub. So to create a Venn diagram, the things that are in common go in the center. The things that are unique to each of the sandwiches goes outside the overlap. So now that we understand how to create a Venn diagram, let's use it to find the greatest common factor and least common multiple. Example 6. Use a Venn diagram to find the greatest common factor and least common multiple of 18 and 27. And you can see I've listed the steps here for solving this problem. Step 1 is to factor each number. So what we're going to do using a factor tree is I'm going to factor both 18 and I'm also going to factor 27. So let's start with 18 in our factor tree. Any two numbers that multiply to give us 18, I'll start with 2 times 9. 2 is prime, so that one's good, but I got to break 9 down again. So 3 and 3. So there is 18. When I factor 18, that's what I'm going to get. 2 times 3 times 3. Let's go to 27. 3 times 9. Again, the 3 is good, but the 9 needs to be broken down. So 3 times 3. So there's my factorization for 27. Okay, so I need to write these down and save myself a little space here. So the factors for 18, 2 times 3 times 3. And the factorization for 27 was 3 times 3 times 3. So step 2 is to fill in the Venn diagram. You notice I've drawn a Venn diagram. This circle is going to represent 18. This circle is going to represent 27. So remember, to fill in the Venn diagram, the things they have in common are going to go on the overlap. So let's start there. Let's take a look at our factors. And if you look at 18 and 27, they have a pair of 3's in common. So I'm going to write that 3 in the overlap. Notice I only need to write it once because it gets counted in the circle for 18 and it also gets counted in the circle for 27. Let's go back to our list of factors. They have another pair of 3's in common. So again, I'm going to list that 3 one time in the center, in the overlap. Now, we have to look at what's left. It looks like 18 also has a factor of 2. That is unique just to 18. So that 2 is going to go out here. And it looks like 27 has one more 3, and that's not a factor of 18. That extra 3 or third 3 is not a factor. So that's going to go out here in 27's circle. Now that we have our Venn diagram filled in, we can find the greatest common factor, and the greatest common factor is in the overlap. So to find the greatest common factor, all I have to do is multiply those factors in the overlap, which is just 3 times 3, which will give us 9. So the greatest common factor of 18 and 27 is 9. Now let's find the least common multiple. Well, the least common multiple, we're going to multiply all of these factors together, all the factors in the Venn diagram. So I'm going to have 2 times 3 times 3. That takes me through the overlap, and then I need one more 3 in that 27 over there. And now I'm just going to multiply those factors together to get my least common multiple. So let's see, 2 times 3 is 6, times 3 again is 18, and 18 times 3, well, we don't know that one right off the bat. So let's come over here on some scratch work. We'll multiply 8 times 3. Well, let's see, 3 times 8 is 24. Carry the 2. 3 times 1 is 3, plus 2 is 5. So it looks like the least common multiple of 18 and 27 is going to be 54. Now it's time to check your understanding of using a Venn diagram to find the greatest common factor and least common multiple. Hit pause on your video player and answer guided practice 5. When you're done, hit play to see how you did. Question 5. Use a Venn diagram to find the greatest common factor and least common multiple of 12 and 15. Step 1 is to factor each number. So we're going to take 12, break that down. Let's see, 3 times 4, and then 4 is 2 times 2. So there is 12 when I get its prime factorization. 15, 3 times 5, both of those are prime, so we're done. So I'll come over here and write the factorization for 12 is 3 times 2 times 2, and the factorization for 15 is 3 times 5. Okay? I have my Venn diagram set up, one for 12, one for 15. Let's first take a look at the overlap. So we come over here and we're looking for common factors, and sure enough, 12 and 15 both have a common factor of 3. So that 3 is going to go in the overlap. 12 also has factors of 2 and 2, so they're going to go outside over here in the circle for 12. 15 has a factor of 5, and that's going to go outside over here in the circle for 15. Now the greatest common factor is going to be the factors in the overlap. Well, that's easy. There's just one. So the greatest common factor is going to be 3. The least common multiple is going to be all of these factors multiplied together. So we're going to go 2 times 2 times 3 times 5 to get our least common multiple. And let's see, 2 times 2 is 4, times 3 again is 12, and then we're going to take 12 times 5. Happen to know that one right off the top of my head. That's 60. If you didn't know that, you'd have to just come over here and some scratch work and figure that out.
If you found this video helpful, I encourage you to check out our other videos that we have on YouTube, or visit the web address that accompanies this video to learn more about our approach to learning mathematics.